Okay, so I managed to find a quiet space at least for 5 minutes in order to record this. Today we're going to talk about the law of cosines. Here's some things that are going to be handy to know about. You should have a knowledge of side, 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 and side, angle, side, triangle congruence. And you should have some knowledge of the law of sines since we talked about it for half an hour last class. You should also know about Pythagorean theorem, and you should have a general knowledge of right triangle trig. Okay, so here's another triangle, triangle ABC. We want to find the measure of all the angles of triangle ABC. It's not a right triangle, so we can't use right triangle trig on this. And if you remember the law of sines, sine of A over A equals the sine of B over B, which equals the sine of C over C. I don't have any of these ratios, so I can't use the law of sines. That's where we're going to learn about the law of cosines. So here I have triangle ABC, and all the sides across are labeled from their respective sides A, B, and C. And I have an altitude that drops down from angle C to side C, splitting up my triangle into two sides and side C into two lengths. So this side we're going to call this side X, and because this whole side was C, but I'm not going to include this part, we're going to call this C minus X. Next thing I'm going to do is use Pythagorean's theorem to write an equation to relate this triangle here to its sides. You'll notice that here is the right angle, and that K is one of my sides, so K squared, and C minus X is also one of my sides, plus C minus X equals the hypotenuse, B squared. Now I'm going to do the same thing for the other triangle. Here's my other triangle. Here's the right angle. And K squared plus X squared, my two sides, equals A squared. You'll notice that both of these equations have K squared in them. So I want to solve for K squared, and I'm running out of room over here, so I'm going to write up here. The first equation, K squared, if I subtract C minus X from both sides, I end up with K squared equals B squared minus C minus X squared. And I can simplify that further if I expand C minus X squared. You're probably not going to think this is pretty, because it's not C squared minus X squared. It's C minus X times C minus X, which gives me C squared minus CX minus CX, so minus 2 of those CX's, and then negative X times negative X is positive X squared. Okay, and then I'm going to distribute this negative sign right here to the other numbers in the parentheses. So that's going to be minus C squared plus 2CX minus X squared. Keep forgetting to write those squares. Okay, now I'm going to take this other equation over here and solve for K squared. That's a lot easier. And I get A squared minus X squared. Now that I have both of them set to K squared, I can, because they both equal k squared, I actually can set them equal to each other. So on this side of my equation, that's because k squared equals k squared. So that means that this side of my equation has to equal this side. So a squared minus x squared equals b squared minus c squared plus 2cx minus x squared. Confused yet? Sorry. Okay. Now you'll notice that there's an x squared I can eliminate here. If I add x squared to both sides, these are going to cancel out, and I'm left with a squared equals b squared minus c squared plus 2cx. Well, that's it. You know, I think I feel like solving this for b squared. So let's take and solve this for b squared. That means I have to add c squared to both sides. I'm actually going to move the b squared over here, and that's going to be a squared plus c squared minus 2cx. Alright, I have to erase some of this crap because we're going to run out of room if I don't. Where's my big eraser? That is the wimpiest eraser I've ever seen. Let me see if I can find a bigger one. Nope, still wimpy. Maybe I don't want to erase that badly. Nope, that's a laser. Nope, I don't want a Christmas tree on it. Oh, for God's sakes, just give me the darn eraser. $1,000 for a piece of junk that I can't erase. All right, we're moving on. Okay, back to the pencil. So, over here, you'll see that I still have x. I want to try to get rid of x. If you look over here at this triangle, I could say that cosine of b, angle b, equals adjacent over hypotenuse. So that's x over a. And if I solve for x, that means that x equals a cosine b. I can go ahead and replace this x in here with a cosine b. Alright, and then I'm going to clean that up a little bit. So b squared equals a squared plus c squared minus 2. I'm going to put the a first because I like to put things in alphabetical order. So b squared equals a squared plus c squared minus 2 times a times c times the cosine of b. And that is the law of cosines. Okay, so since b squared equals a squared plus c squared minus 2 times a times the cosine of angle c, that means if we know all three sides, the only thing we don't know is the angle, and we can solve for the angle. But what happens if I move these, if I call these A, B, and C? Can I still use the law of sines? Well, of course you can. You just change the formula a little bit. A squared equals B squared plus C squared minus 2 times B times C cosine of A. Or if I wanted to change them again and find c squared, well, that equals a squared plus b squared minus 2a times b times the cosine of c. Oh crap, I think I said that before. That means up here it's the cosine of b. A classic Hazelton mistake. But those are your three formulas for the law of cosines. Here's an example of how to use the law of cosines. Here I have triangle ABC, and I have two of the sides. I have side C, which is across from angle C, and I have side B, which is across from angle B, and I know the value of angle A, but I don't know the value of side A, and I'm asked to find the length of the missing side. So I'm going to use the form of the law of cosines that has angle A in it. So that's going to be a squared equals b squared plus c squared minus 2b times c times the cosine of A. And then I'm going to fill in the values that I have. A squared I don't have. B squared is, God, I'm blind, 21 squared, I hope that's right, plus 15 squared. Wait, it's my problem, so who cares? You won't know. 2 times 21 times 15 times the cosine of 105. Oh, just a side note, that's 105 degrees. So your calculator probably should be in degrees, right? And if you're going to be foolish and try to put this in your calculator all at once, well, you need to put parentheses around all of that, or you're going to have a problem. So 21 squared is 441 plus 225 minus 630 cosine of 105 which makes this 600a squared equals 666 minus 630 times the cosine of 105. If you're doing this in one step, please put the parentheses around that so it doesn't do 666 minus 630 first, because the order of operations say that this has to be together. When I'm done, I need to take the square root of that. And I end up with A is about 28.8 centimeters. Here's one for you to try. Pause the recording for a little while you work out the solutions. When you're done, restart it and check your answers. Okay, so hopefully you got 3.4 kilometers. I don't like how this is written. If I were doing this problem, I would relabel this triangle. I would label this angle A, just so I know what I'm doing. I always take the extra step to label things. B and C, you know how forgetful I can be. I'd call this A, this B, and this C. And that way, and I'd call this A squared, A, and A squared. That way you know what you're looking at. Just some helpful hints. So what happens when I have all three sides and I want to solve for an angle? Well, you can rearrange this formula to make it solve for the angle. If I add 2bc cosine A to both sides, I get 2bc cosine of angle A plus A squared equals B squared plus C squared. I need to subtract the A squared from both sides, and I end up with 2 times B times C times the cosine of A equals b squared plus c squared minus a squared. Doesn't leave me quite with my angle alone. I still need to do a little division. 2 times b times c. If I divide by that, I'm left with the cosine of a. So the cosine of angle A equals b squared plus c squared minus a squared, all of that divided by 2 times b times c. And remember, if you're plugging this into a calculator, you've got to protect your fraction. You have to put parentheses around the top and the bottom. Once you do that, in order to solve for angle A, then you're going to use your good old friend arc cosine. Or some of you like to say cosine to the -1. I hate that. But this will give you angle A. Oh look, it's all typed up nice and pretty for you. So here's an example of how to find the angle. You'll notice that I'm looking for angle C. Okay, so I need to use the form that has cosine C in it. That means that instead of subtracting a squared, I'm going to subtract, you got it, c squared. So it's going to be a squared plus b squared minus c squared divided by 2 times a times b. I'm going to fill in the values that I know. Cosine of angle C, that equals 8 squared plus 5 squared minus 7 squared over 2 times 8 times 5. And that equals 64 plus 25 minus 49 divided by 80, which means that cosine of C equals 0.5. Hey, wait a minute. Do we need our calculator to figure out where angle C is 1/2? Think, guys, unit circle. Where is the cosine 1/2? Cosine is the x value. So it's up here at 60 degrees. You can check that with your calculator. If you needed your calculator, you would do C equals arc cosine of 0.5, and you'd see that it is indeed 60 degrees if your calculator is in degree mode. What would the answer be if it's not in degree mode? Somewhere around 1. It won't be exactly 1, but it's pi over 3, and 3.1 divided by 3 is close to 1. Here's one for you to try. Turn this off and work out the solution. When you're done, turn it back on and check your solution. Okay, again, I would relabel this A and this A, and I'd call this B and this C, just to help me out. I need all the help I can get. And then you plug it into the formula. Cosine of A equals B squared plus C squared minus A squared. Again, I'm subtracting the angle the side that I have the angle for. And the other two sides are in the denominator. And when I calculate that out, I get cosine of A equals negative 26 over 70. And the way to get the angle by itself, angle A, is you need the inverse function, which is arc cosine. On the calculator, it looks, no, it doesn't look like that. It looks like cosine to the negative 1, but it's arc cosine. And then I get the angle of 111.8 degrees. That's it for today.